Hi everyone, this is Darren here, and today I'm going to teach more about subtraction of algebraic fractions. So without further ado, here's my first example. So suppose we have 9x over 3k minus 3x over 2k. Alright? So the first thing I like to tell my students when it comes to algebraic fractions, especially subtraction or addition, is always denominator, 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 right? So now here, the denominators are different. So what we have to do is really focus on these two and ask ourselves, how can we make these two the same? And you take a moment and pause, think about it. You realize that actually 2k and 3k has the LCM of 6k. And how do you go about to get 6k from these two numbers? So to get 6k from 3k, I need to multiply by 2. And to get 6k from 2k, we need to multiply by 3. So let's go ahead and do that, alright? So I get a 6k here. Okay, so I multiplied 3k by 2 to get 6k. But maths, you have to always be fair, right? So if I did it to the denominator, I must do it to the numerator too. So therefore, if I multiply by 2 here, 3k times 2 to get 6k, must multiply 9k times 2 also. So this just gives me 18x, right? Because 9x times 2 gives me 18x. Alright, so now over here, we do the same thing to get the denominator of 6k. So this will be 6k. So 2k times 3 giving me 6k. And now 3x times 3, right? Because we have to do the same. So I multiplied 2k by 3, so therefore multiply 3x by 3. Hence, this just gives me 9x, alright? So we are on our way to solving this question right now. So that's, since the denominators are the same, 18x minus 9x can just be solved with the next step. So therefore, this just gives us 9x over 6k. And then we can simplify one step further, as both of them can be divided by 3. Hence, we can rewrite this as 3x over 2k. And this will be the final answer for this first example. Alright, so let me move on to the second example now. Okay, so for the second example, we have 3m minus n over g minus n minus m over 4g. Alright, first thing, right? Focus on the denominators. So we have g and 4g. I can make this g to 4g just by multiplying by 4. So let's go ahead and do that. So I have a 4g here. And now if I multiply the denominator by 4, I must multiply the numerator by 4. And 3m times 4 gives me 12m. And minus n times 4 gives me negative 4n. So therefore, we have changed this term here successfully to this. And now the denominators are the same. So this just gives me n minus m over 4g. Alright, so now these are the same. We can go about solving, and we can just solve it as such. 4g, so 12m, and there's m here, right? So we have to put them together, but 12m minus m? But you would be wrong, because it is a minus m. So when you have a 12m minus m, it becomes equivalent to a plus m. So this will just be 13m actually. Okay? And now here, minus 4n, minus n. So this will just give us minus 5n. So yes, with that step, we have gotten our final answer for this example 2. So now let's move on to example 3. It gets more tricky because I'm going to introduce terms with brackets now. But that'll be fine. As always, always focus on the denominators first. So let's see what we have. So suppose we have 3 over x plus 4 and 2x minus 1. This is minus, then we get this, x plus 1 and x plus 4. Alright? So this is the question. So now we focus on the denominators. We see that if I multiply 2x minus 1 into this denominator, we would get the same denominator, right? So that's the trick to this question. Although they're in brackets, we must be able to see that x plus 4 and this x plus 4 are already the same. So the only difference is that here we have multiplied by 2x minus 1. So actually we can do that here, right? Why not? It's fair. So if I multiply 2x minus 1 here and 2x minus 1 here, we would be one step closer to solving. So let's go ahead and do that. So I'll just rewrite this here quickly. Okay, so this will be just alright, so now notice that I've introduced brackets on my own. And this is a really important step, because if you do not introduce the brackets, and let's say you just put in x plus 1 and you put the 2x minus 1 here in brackets, right, without introducing your own brackets, you'll be wrong, because mathematically this would mean the 1 is to be multiplied by the 2x and the 1 will be multiplied by the negative 1. It means that the x does not get multiplied with this, which is wrong, because we want the whole chunk on top to be multiplied by this. So that is precisely why I've introduced the brackets on top. And likewise, I've introduced the brackets on the denominator here. So now, the denominators are already the same. We just have to actually expand this out, alright? So I'll go ahead and expand this out over here, separately, and then later transfer this answer from here to here, alright? So x times 2x, what does this give us? It gives us 2x squared. And now, 1 times 2x gives us positive 2x. And now, negative 1 times x giving us negative x. And negative 1 times 1 giving us negative 1. These two are the same terms, so we can join them together. Plus 2x minus x, so this just gives us plus x. Now, I'll transfer these three terms on top here to replace this. Alright? So, let me just go ahead and do that, and please follow along. So we have now 2x squared plus x minus 1, right? Okay, so now we are actually, in the next step, we are ready to solve. Can you see it? Alright, I hope you were able to see, okay? So we just have to combine this 3 with this. But one thing to take note is this negative sign. Because when it comes to subtraction of algebraic fractions, it is slightly more tricky because of this negative sign. When we are faced with a negative and negative, we must be sure to flip it in our minds, okay? So just take note of that as you're about to solve on the last step. So the last step will be as such. X plus 4, 2x minus 1. Okay, denominators will be combined because, I mean, they're the same, right? So we can just put it here. And now, we're going to go 3 minus 1. So this becomes 4, okay? This minus 1 becomes a plus 1 when we have two negative. So now, and then later on, we're going to have this term, right? So it'll be negative 2x squared. So negative 2x squared. And then here will be negative plus x. So minus plus x becomes just minus. So this becomes minus x. And therefore, we have found our final answer. So, I guess this one is slightly more complicated, right? Because there's brackets and everything. But if you see the brackets, don't be deterred. Always focus on the denominator, and then later expand as necessary, and later on simplify as necessary, and you will get the answer, okay? Alright, so let me move on to the fourth example now. This fourth example is something I personally quite like because, okay, I'll show you why. So we have 5x over x minus 7 minus x minus 1, 7 minus x, okay. So I personally like this example because the denominators is quite tricky. They are similar because 7 x and 7x, right? But they're in different order. So, see, this one x comes first, this one 7 comes first, right? So the trick here is to make the denominators the same. Always, that's the trick. But how do we do so? Well, we can do that by factorizing out a -1, right? Let me show you how, what I mean. I can just rewrite this as same minus 1 minus 1 x minus 7. Okay? You see now what happens? I factorize out -1. If I were to expand it back in, would I get the original? Let's check. -1 times x giving me a minus x, and it's -1 times -7 giving me +7. So therefore, this step here is correct. But now, we have different denominators, don't we? Okay? So let's make our denominators the same. I can introduce a -1 here, right? So I introduce a -1 here. Let's do that. Put -1 here. But if I'm introducing a -1 to the denominator, must also introduce it to the numerator. So therefore, this will be okay. So this will just become -5x. Right, let me just change that. Because -1 times 5x gives us -5x. Alright. Okay, so now that the denominators are the same, we can just go ahead and combine the numerators. So we can do that with this step here. -1, x minus 7. And now this will be -5x, okay, minus x. So -5x minus x will be -6x. Okay, so let's write down -6x, and then -1. Again, -1 will be +1. Good, if you were able to see that. So two negatives becomes positive. So therefore, this will be our final answer. It's fine to present it as such, or if you don't like too many negatives here, you also can remove the negatives if you want. If you would like, you could just, instead of writing as -1, you can divide both sides by -1. So if you do that, you will get 6x minus 1 x minus 7. Okay, so both of them are fine. Alright, so let me move on to the last example now. So in this last example, we have 10 minus 3x over 7, 2x minus 3 minus 5 minus x over 14, 3 minus 2x. Okay? So, if you notice, the pattern is a bit similar again. So we should really focus on this part here, right? So 2x and 3 and 3 and 2x. So we can always flip this as, if you recall the previous example, that's what we did, right? So let's go ahead and flip this. I'll factorize out a -1. So I will just put this as -14, and I will flip the positions. Okay, 2x minus 3. Okay. So now, what happens? We've compared the denominators again. The only difference is this is 7 and this is -14. So to get this, to go from 7 to -14, what must we do? Okay, we must just multiply by -2, right? 7 multiplied by -2 gives us -14. And that's what we are supposed to do here. So if I do that here, on the denominator, we must do that to the numerator too. So we must be very careful now. So we'll be multiplying by a negative number. So I multiply this with a -2, it gives me -20, and this with a -2 gives me +6x. And then we minus 5 minus x here, minus 14, 2x minus 3. Okay. So denominators are the same. Now we can just go ahead and simplify the numerators. So I'll rewrite the final answer here. And it will be just equals to, okay, minus 20 minus 5, so it'll be minus 25. And 6x minus x will be, yes, this will be minus x, so this will be a plus x, so 6x plus x, giving me positive 7x. This will be just minus 14, 2x minus 3. Okay. So alright, this is fine. And this is our final answer. So I hope that you learned something from this video, and as usual, please feel free to like, subscribe, and ask questions in the comments below. And with that, thank you so much for watching this video. Goodbye.